The loci of any expression, it means that how much coverage for that expression. So the coverage could be just a line, could be just a point, could be a circle, could be only the circumference of a circle. It depends on the expressions and the conditions. So the loci itself, if you want to think about it, is similar to coverage in cell phone towers. So sometimes you want to call and they say there is no coverage. That means the closest cell phone tower that exists in that area, their loci does not cover that area, or it's not big enough to be extended to that area. Okay, so that's why they say there is no coverage. So in loci, there are three different types of loci that we're going to discuss for complex numbers, or for the expressions for the complex numbers. So the first one is what type of expression that result, the loci for that is result as a circle. So the type of expressions like the modular of a complex number that equal a number, or it could be a modular of a complex number minus a real or another number equal a number. Okay, so it's always the modular of something is equal a number. And then we'll discuss when it's greater than or less than or smaller than and so on and so forth. So then the loci equal a number. So for example, because we know these type of expressions, this one as well could give us a circle as a loci. Okay, and I'm just gonna write another one in here. We'll just do less than and equal this time. Okay, so because we know it's a circle, so a circle needs a center and a radius. So the radius of the circle is always the number that you get given, which is the 5 in this case in here. And the center you get it from the inside the modular. So for this case here, the center is 0, 0, because there is no difference between the z, the general complex number, or any other number. So this one here is a circle. With 0, 0 as in a center and 5 equal radius. So if you want to draw it, it will be like that. This one here, it's there is a difference between that number, so for that one you need to prepare your expression first before you can find the center of the circle. So first we need, as I said, because we know these type of expressions or these type of loci give us a circle, so we need to find the number and we need to find the radius. So for this one here, you need to prepare it. Preparing it is taking the negative out of the, it's always you rewrite it as z minus whatever number you get. Okay, so anything that has negative as a common factor. So anyway, rewriting it as minus the difference between the two expressions. And then this one will be your center. Okay, so the center, because it's only real components, remember real means the x coordinate and imaginary is the y coordinate. So this one here will be the circle with center 2, 0 and radius equal 10. This one here, you can see you've got two components. So again, I need to prepare it first. Okay, take negative out. This gives me 3 minus 2i. Okay, when you expand this negative, you should get this expression. This one means the center for that is 3, negative 2, and the radius is 3. This one, again, we're just repeating it. We just prepare it. So that means is the center. And the radius is 4. Okay, so now but the difference in here, this is just a circle, so this is all of these, they want this, the locus is the circumference of that circle. So that's the locus is the circumference of the circle. This one here, but this circumference, so this one as well is the circumference of the circle. This is the circumference of the circle, but this one here is less than or equal. It means that you will have to shade in or out. So when it is less than or equal, mean that the locus needs to be less than 4 or equal to 4, mean I want the circumference of the circle and shading inside the circle. So for example, in here is first we draw the circle, -2, 3. So we got -2 and 3 up here, and we go 4 by 4, and then the loci is actually shading inside the circle and including the circumference of the circle. Okay, if it is greater than, means shading outside the circle. Okay, if it's equal, mean you only want the circumference. The second type of loci that we're gonna discuss, or the second expression of loci, is when the answer is always a line. So you need to find the equation of a line. So for example, if you have z plus 3 minus 2i equals z minus 4 plus I. So remember, this is when there's 2. So this one here is the modular. Okay, so you want to just open the modular for those two equations, sorry, between the two complex numbers. So z is one general complex number, so the z can be written as x plus yi, just general complex number. So that's why we're gonna rewrite that as the modular between those two will be x plus 3 square plus y minus 2 square equal, and then we're going to do the same in here. We're going to have it as x minus 4 square plus y plus 1 square. And now remember, when we solve these type of equations, we have to solve it, rearrange and simplify. So to rearrange this type of equation, because we've got square on both sides, so the first step is you're going to square both sides to get rid of the square root, and that's why you'll end up with this. That's one. And then now you expand and simplify. So when expanding, plus 9, then you're expanding this one here, then equal expanding that, and then now when you simplify, you can see the x squares and the y squares will be simple out. And now rearrange as a line equation. So rearrange as a line equation mean all the y's in one side and all the x and the numbers in the other side, because the equation of a line, just a reminder, the equation of the line is like that. Okay, so you can tell the gradient and the y-intercept. So for this one here, you rearrange. So we've got the y on this side here, so we have 2y, 4y, so that gives me 2y on this side, just moving that in here. And then now I have negative 8x, and moving the 6 give me negative 8 plus, sorry, minus 6x, and that gives me negative 14x. And then that we have 2, 4, yeah, that's right. And we have the 9 and the 4, that one gives me 13. And here I have 17. So taking the 13 on this side, so I'm left with 17 minus 13 was 4. So it's plus 4. Plus 4. And now obviously I want the y. So that's why I'm going to divide by 2. Oh, sorry, made a mistake in here. That's a minus. So that means that gives me 6. Negative 6. Okay, so now you either rearrange and make it equal to 0 everything. So I could have negative 6y plus 14x minus 4 equals 0. That's one type of the equation. Or I can divide by negative 6 to have this format of the equation. So y equal negative 14x over negative 6 plus 4 over negative 6. Simplify. It's giving me 7x over 3 minus 2 over 3. So you can draw a line with 7 over 3 is a gradient, and the y-intercept, it's negative 2 over 3. Okay, the last type of loci, when it's also a line, but you need to identify first the starting point of a line. And this one is using the argument. Okay, so for example, you could have something like that. Okay, so for this one here, the starting, because you only got the complex number, so the starting is 0, 0, and pi over 4 is your argument. Sorry, that's the argument. Okay, so the pi over 4 is your argument. So the argument, remember, from the real to the line. So your complex, your loci is this. But if you have something like this, for example, something like that. So that means first you will have to identify your starting point, and you're going to use this complex number but for your starting point. So we need to prepare it first by taking the negative as our common factor. Minus 3i. And then you will have to put this point here, 2, negative 3. So it's 2, positive 2 in the real part, negative 3. So the point is here. And then from here, this is your imaginary real parts and imaginary parts. And then you will have to do pi over 2, which is 90. So your loci is this. So this is kind of your imaginary parts. Are you? What a type of game that you're not even talking